Let's be honest. Is it possible that you have taken your eyes for granted? Have you ever thought of how amazing the human eye is? The way we can see millions of different colors and objects in various shapes and sizes. Well, indeed, the eye is a fascinating part of the body. In fact, it's only second to the brain in complexity. It's really fast. Image processing takes only 13 milliseconds. How did I realize that the eyes are important? I'm Boggs, and this is my story. Let's start when I was 10. I was a troubled kid, but let's not dig into that. So my parents signed me up into sports to consume my energy, and really to stop me from causing trouble. Fast forward, I discovered MMA, which my parents don't really support of me doing. But I understand, because it must be really painful watching your kid getting punched in the face. Still, despite their disapproval, I'm now an amateur MMA fighter. Professionally trained, physically and mentally in anticipation of a future fight. And finally, one day, the most awaited news came. A fight match was arranged. So we hit the gym, intensified the training, incorporated the sparring to build a game plan. Sure, injuries and cutting weight are part of it, but that's what makes it so challenging before the event. But during a sparring session, my partner's shin accidentally landed into my eye, which dropped me. Everything turned light green for 5 seconds or so, and the pain was so excruciating. We stopped immediately and went to the ER. After a lot of examinations and procedures, the doctors told me it was the detached retina injury. I didn't know it was bad until I got home and looked it up. So now it got me thinking, how do the eyes really work? The eye is a sensory organ for light detection and visual perception. It is shaped like a globe or fishbowl, found in the bony orbital socket in the head. It is divided into two parts. The anterior segment, which is the front part, and the posterior segment, which is the back part. First, let's look onto the anterior segment, which again forms the front part of the eye. We have the cornea, a perfectly clear watch glass that protects the eye. I wonder if that's why they call the eyes the window to one's soul. Anyway, we have the pupil, which is like a tunnel through the center. Now here's another interesting part, the uvea. That is further composed of the iris, the ciliary body, and the choroid. Let's tackle them one by one. Ever wonder why we have different eye colors? Like yours is dark brown, I have the black one. There's also the green ones and the blue. Well, that's because of the iris, which has circular muscles. It creates the anterior and the posterior chamber. These are spaces filled with the aqueous humor, a fluid produced by the ciliary body. Well, aside from that, it provides attachment for the suspensory ligaments, called the zonules of Zinn. And in turn, the spongy-like cords attach to the lens, fixing it at the center of the eye. And lastly is the choroid, which nourishes the inner part of the eye. Phew! So that's the front. Now let's go to the back of the eye, the posterior segment. So here we can find the sclera, a firm, white, strong, and elastic structure that maintains the eye's circular shape. It is also where the muscles insert themselves. Next is the choroid. Isn't it amazing that it is also part of the posterior division? Now we have the retina, the innermost part of the eye, which has the central role to play in allowing us to see. We'll get to know the retina more when we talk about how the eye works. Occupying the largest space in the eye is the jelly-like vitreous humor. Amazing how this organ is like a pool filled with water. Aside from that, this jelly even maintains transparency of the optical media and gives off a constant internal pressure to support the other internal structures. Last but certainly not the least is the choo-choo train to the brain, which is the optic nerve. This is because it transfers visual information from the retina to the vision centers of the brain. But how does the eye work? Apparently, to form a proper image, the eye does not work alone. The brain and the eyes work together in order for vision to work and for an image to be properly viewed and recognized. In a nutshell, the eye locates the patterns of light rays and sends these to the brain, which transcribes these light rays into images. So to further expound on how the eyes work, the process goes like this. Light has an index refraction of 1. When it hits an object, let's say a punching bag, The light bounces off the punching bag and goes to the eye, first hitting the cornea. The cornea has an index refraction of 1.376 and has the strongest refracting power from all the other parts of the eye. The cornea makes the light rays sharper and clearer. Then, light passes to the pupil, which is surrounded by a colorful ring known as the iris. The iris controls how much light enters, so this means when I'm in a dark room, the iris widens the pupil to allow more light to enter. But when I enter a bright room, it narrows down my pupil to reduce the light that enters. Oh, by the way, the eye has a watery fluid termed as the aqueous humor, with a refraction index of 1.336, and yes, the light passes through here too. Light will then hit the lens, which functions to help focus it, through a process called accommodation. This process works in two ways to accommodate seeing objects from far away, or distant vision, and the objects up close, or close vision. It goes like this. When looking at the punching bag far away, light rays from the object are nearly parallel, and while looking at it, the annular ciliary muscle of the eye is relaxed, causing tension to increase in the zonular fibers. This causes the lens to flatten. This is distant vision. On the other hand, when looking at, let's say, a pair of MMA gloves up close, light rays from the MMA gloves diverge and would need more refraction and focusing. This means that the annular ciliary muscles of the eye contract to reduce tension in the zonular fibers, causing a curvature of the lens. This leads to an increase in optical power. This is close vision. After passing through the lens, light now passes to another fluid in the eye. This time it's gelatinous. It's called the vitreous humor. So when all of these mentioned structures work together, they aim to focus all these light rays to the back of the eye, where the retina is found. The retina is the light-sensitive area of the eye that contains millions and millions of photoreceptors that would basically function to detect the light focused and then transform them into electrical signals. To elaborate, when light hits the retina, photoreceptors are activated and convert light into electrical impulses that are sent directly to the optic nerve. But before continuing to the optic nerve, let's chat about the other shenanigans that go on in the retina. There's an area in the retina called the fovea centralis. This structure has the highest amount of photoreceptors and is crucial for the sharp or foveal vision, where an image is seen in the highest visual resolution. But there's also an area where no photoreceptors are found, and this is the optic disc. When light hits this area, no image is generated, thus called the physiological blind spot. That is a lot going on in the retina. It's really unfortunate of me having sustained such injury to this part of the eye. Anyway, let's get back on track. So again, when light hits the retina, it converts light to electric signals sent to the optic nerve, forming the optic chiasm, then finally the optic tract. The optic nerve plays a crucial role of being the bridge that connects the eyes, specifically the retina, to a special part in the brain called the visual cortex. Now remember, the retina views an image upside down, and that each side of the eye has a slightly different view. It's the brain's job to turn this image right side up and combine all the views into one image. This is how the eyes and the brain work together. Now I know what the injury meant. Everything I had worked hard for, my goals, are all gone. The practices, the arguments with my parents. I was advised to undergo surgery and avoid contact sports for a while. But I will be back after completion of my recovery. One thing that I learned from this injury was to be thankful for the gift of sight and use it productively. Think about all the things you're doing today. How many of those things are dependent on your eyesight?